Good morning, everyone. I am Jonaline de la Cruz Severa. I am from Section 80. Today, my video presentation is all about the mathematics in nature and sets. The first one is we're gonna talk about mathematics in nature. So, in this introduction, I will not discuss this because it is just an introduction about mathematics in nature. Let's just proceed in the main topic, which is the patterns. Pattern is a thing that is repeated or recurring arrangement, form, or design following a rule or a sequence. And these are the classification of most common patterns in nature. The first one is symmetry. Symmetry is a pattern that shows reflection of images. The first one, the categories of symmetry are radial symmetry and bilateral symmetry. Radial is a symmetry formed around a central axis, while bilateral symmetry is a concept that two opposite sides have identical features. Here are some examples of symmetry in nature. The first one is bridge, the second one is starfish, the third one is butterfly. The second one is fractal. Fractal is a pattern which repeats at progressively smaller sizes and angles. As shown in Figure 1 to 2, it demonstrated a Pascal's triangle. Pascal triangle is introduced by Blaise Pascal, a French mathematician. Pascal triangle is a triangular array of numbers in which those at both sides of the rows are 1 and others are the sum of the nearest two numbers in the row above. Pascal triangle is used as concept in the transformation of fractal shown in figure. Here are some examples of fractals. First is fern, second one is snowflakes. Snowflakes is classified also as symmetry because aside from its flakes growing in different sizes, it also shows radial symmetrical features. The third one is aloe polypila. It is an example of fractal also. It has a spiral fractal characteristic which is most commonly called spiral aloe. The third one is spiral. Spiral is a pattern that moves around at a central point and continuously widening. As shown in figure 1 to 3, it shows a spiral pattern derived from Fibonacci sequence, popularized by Leonardo of Pisa, most commonly known as Fibonacci. Fibonacci sequence is the series of numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Wondering why they are not in a sequence, for example 1, 2, 3, 4, 5. It's all because the next number is the sum of the two numbers before it. For example, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 8 equals 13, 8 plus 13 is 21, 21 plus 34 is 55, and so on. Here are some examples of spiral in nature. The first one is seeds of a sunflower. Second one is giant wave. And lastly is the snail shell. The fourth pattern is a tessellation. What is tessellation? Tessellation is a pattern that repeats figures closely, fitting together with no gaps in between. As you can see in the figure 1.4, the polygonal packing shows three polygonal packings, namely triangle packing, square packing, and hexagonal packing. Examples of tessellation are honeycomb. Honeycomb structure is natural and created to efficient use of space. The second one is pineapple fruit. It is also an example of tessellation. So, let's proceed to lesson 2, which is the sets. So, what is sets? Set is a collection of objects and represented with a capital letter. Example A, the set of available gadgets. B is X over 2X is a set of shapes. C is 2, 4, 6, 8, 10. roster method. N is equals to 1, 2, 3, 4, 5, and so on, as shown in the third example. The roll method is n equals to x is the set of numbers from 1 to 100. The symbol quotation is read as such that, as shown in the second example. So let's proceed to the elements. Elements is the objects being collected in a set. If x is an element of set A, it is written in the form of x equals to A. The other one, if x is not an element of set A, then it's written in the form of x is not equal to A. Universal set is a set that contains all the elements of the given set. It is denoted by U. Example U. X is a set of all letters in the English alphabet. So U is a set of all land transportations. Empty set is a set with no elements. It is also known as null set and denoted by Subset is a set of elements that belongs to a set given a set X and Y. Set Y is said to be subset of set X if all elements of set Y belong to set X. Subset is denoted by this symbol. For example, given set is x 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and a set y is 3, 5, 7, 11, 13, 17, and 9. A set y is a subset of set x. Since all the elements from set y are found in set x, it shows that y is a subset of x. Example, let A, B, C find the subsets of A. Solution: the subsets of A are null set A, B, C, A, B, A, C, B, A, and the set A itself. Note, null set or empty set is always a subset of a set. The cardinality of sets is the number of elements in a given set. Example, let S be the set with the following element B, C, D, F, G, H. The cardinality of set S is set B, C, D, F, G, H equal to 6. Set operations are: the first one is union, second one is intersection, third one is set difference, four is complement. Complement belong to Cartesian product. And that are the practice task assessment. I know you already know and read about this, so I'm not gonna tackle all of these. Thank you for listening, and this is all my presentation.